Alright, well, here we are again with another video lesson, and today we're going to be looking at a couple more ways that we can prove two triangles are similar. So that will give us 3 ways total, and as we go through this lesson I'll try to point out when I would use one over the other. So the first thing I'd like to do is review the one that we learned the other day. That was called angle-angle similarity. Remember, angle-angle similarity just says that if you've got two triangles, that if you know information about the angles, particularly if you can show that one pair of angles are congruent, and then you can show a second pair of angles are congruent, and I don't know what your reasons would be for that, but if you can show two pairs of angles that are congruent, then you would be able to say that these two triangles are similar by angle-angle similarity. I think this is a really good way, really easy way to prove triangles similar if you know obviously information about the angles. So here are other 2 ways to prove two triangles are similar. The first one is called side-side-side similarity. And it says, and you'll have to bear with me here as my whiteboard isn't cooperating especially good right now. So I'll read it and then the whiteboard will catch up here in a second. It says that if the corresponding sides of two triangles are all proportional, then the triangles are similar. If the corresponding sides of two triangles are all proportional, then the triangles are similar. And so what this theorem is really saying is kind of the opposite of the one that we learned the other day. This one is saying, hey, you know, if I only know information about the sides, I don't know anything at all about the angles, I still know that the triangles are going to be similar to each other if all of those sides have the same ratio. If I'm able to, you know, simplify the scale factor to the same number for all 3 pairs of sides, then I know the triangles are going to be similar to each other. So you really don't have to know anything about angles in order to have similar figures, similar triangles. And so again, it kind of just depends on what information I give you on a question. The other theorem we're going to learn right now is referred to as the side-angle-side similarity theorem. Okay, and just like we had earlier this year, this is talking about two sides and an included angle. So if you have 2 pairs of corresponding sides that are proportional, okay, so you have to have 2 pairs of sides that are proportional, and you know that the included angle, remember the included angle is that one that comes in between those sides. So it's real important that the order of these parts is exactly this order as you show your work. So if you have 2 pairs of corresponding sides that are proportional and the included angle is congruent in each triangle, then the triangles are similar. So it's kind of a combination of the 2 other theorems. I don't particularly like this one. I don't use this very often just because you have to know information about the angles and about the sides. But here's a picture just to kind of show you what this is talking about. So there's my pair of angles that are congruent. And now again I have to know information about my sides. If you notice, I'm giving you numbers that put the angle in between those numbers. And so I'm going to look at my ratios here. 3 is to 6 as 5 is to 10. Is that the same ratio? Of course, cross multiplying shows me that they are, and so now I have side angle side. Alright, so those are the 2 ideas. Now we'll spend some time practicing these 2 ideas. And as we always do, we'll start with some easy examples and work our ways up to some that are a little bit more challenging probably. So this first problem, I'm going to draw two triangles for you. And I'll go through this first one, I'll do this one on my own, and then I'll give you one to work on here when we're done. Okay? So in this one, you've got triangle ABC, and you got triangle DEF, and this is the information you know. You've got those side lengths, 4, 8, and x minus 1, and 12, 18, and 3 parentheses, x plus 1. And we're going to try to show or prove or figure out what x is so that these two triangles are going to be similar. And again, what is it that we know? If the triangles are similar, then we know that all of their sides are proportional. So what's the most important pair of numbers in this picture right now? Definitely 4 and 12. Those are the two that you know for sure go together based on the similarity statement, and there's no x's in that. So I'm going to write 4 is to 12 as x minus 1 is to 18. Again, I want to be consistent. I want to make sure that I'm matching up the parts that correspond to each other. So cross multiplying here, I got to make sure I use distributive property. And I'm going to have 12x minus 12 equals 72. And when I solve that for x, I'm going to add 12 and divide by 12. I get x equals 7. Now I can't stop here because I have to make sure that the last pair of sides also have the same proportion. If only two pairs of sides are proportional, it's not similar. So I have to make sure that I have the third side now. So again, I'll go back to my original ratio, 4 is to 12, as 8 is to, and I'll just distribute that out, 3x plus 3. It'll be a little bit easier instead of having to distribute and then distribute again. Just kind of get rid of those parentheses there to start. Alright, so I'm going to cross multiply now, and that's going to give me 12x plus 12 equals 96. And so I'll do some math here to solve for this. Subtract 12 from each side to get 84, and divide by 12, and I get x equals 7 again. And so I know that x is 7, and when x is 7, all three sides are proportional. Alright, so what I'm going to do right now is I'm going to put a very similar problem up here on the board. Once I do that, I'd like you to push pause on the computer and work on this problem. Try to figure it out first. And when you're done, you can push play, and I'll show you just a brief solution to what we're going to do with that. Alright, so here we go. Got two triangles. Give you some lengths. I'll give you some variables or some letters on the problem. And again, I'll be asking you to solve for x so that you know that the three triangles are, solve for x so that the two triangles are similar. So we've got 20, x plus 6, and 12, and that's for triangle XYZ. Don't confuse the letter x on the angle with the x variable. And then on triangle PQR, we've got lengths 30, 21, and 3x minus 6. Right? So just like before, solve for x so that the triangles are similar by side. Okay? Once you have that written down, push pause, and I'll see you in a few moments. Alright, so you started back up. Here's my solution set for this problem. You'll notice that I just reduced my 20 over 30 to 2/3, and I cross multiplied for both sides, and I got x equals 8 in both cases, and that makes the triangle similar. So hopefully you did that. If not, go back, look at my work again if you need to. Okay? Alright, here's a different kind of problem. And so I'll walk through this one with you. I'll just give you one of these. You can kind of go through with me if you like. Kind of listen, jot some things down as we go, and see if I can help you understand this one as well. If you want to follow along, this is on page 391 in your book. I'm actually doing example number 4. And so if the video is going too fast, or if you want to follow along in the book, you certainly can. And so I'm going to show why triangle XZW is similar to triangle YZX. And it's going to get a little bit confusing because those pieces are in both triangles. Right? You're sharing some of those parts in the two triangles. And so it's really, really important as we go through this right now that you use the similarity statements up at the top of the screen right now to help you figure out what parts correspond to each other. And so I'm going to try to show how these two triangles are similar, and I'm going to think about here what method is the best method to show they're similar. I have all three to choose from. I have angle angle, I have side side side, and I have side angle side. All right, and for me, I already have an angle that's marked congruent, so I'm going to go with that one. All I have to do now is show that two pair of sides are proportional. I certainly could do side side side, but it should be easier doing this. So I have to go up at my similarity statement now, and I see that WZ is going to correspond to ZX. And so ZX, I can find that in the figure. And the reason I'm choosing these ones is because these are the sides that are making Z the included angle. Alright, so XZ up in my similarity statement. You can go up here above and you can see that XZ is going to match up to YZ. Alright, so the similarity statement tells you which ones to put together. And those are my two pairs of sides that make angle Z the included angle. And so now I'm just going to plug those numbers in right now. So WZ is 16, XZ is 12. That's 12 again up here on the top of this one. And YZ is 9. And now I can cross multiply. 12 times 12 is 144. 16 times 9 is 144. So those two sides are definitely proportional. And so there's my side angle side similarity. Okay, so I proved the two triangles are similar by side angle side. That's a little confusing. All right, you might want to practice something like that in the homework when I give that to you later. Last type of problem I want you to be able to do. And obviously you can see we're going to put this one on a graph. And what I'm going to do is I'm going to give you a series of points, and I want you to show or prove that the two triangles are similar. So you can jot these points down here as I write them. A is 0, 0, B is 2, 3, C is 4, 0, D is 6, 9, and E is 12, 0. Alright, and I'll go through this first one together, and again I'll give you an example problem to do here at the end, and you can work on that as well. Maybe compare your answer with a partner. So I just plot those points, alright, and so I'll do that relatively quickly here, plotting those. And as I'm plotting those, let me talk to you a little bit about your choices here. Again, you have three choices to how you're going to try to show these triangles similar. Are you going to show them similar by angle angle? Are you going to show them similar by side angle side? Or are you going to show them similar by side side side? I don't know if I said that twice. Side 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 or side angle side. Alright, so any of those are possible ones to use. My advice is that when you're on a graph, the one that will always work is side side side. Alright, angle angle sometimes works. Like if you could show those lines parallel here, then you would know that maybe you'd have some corresponding angles that were congruent, or angle A is congruent to itself by the reflexive property. Alright, if you think you understand that and you want to try that on your own, go ahead. But I'm always going to do these probably as a side 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 problem. What I'm going to do is I'm going to find distances now. So I have to be really good with my distance formula. I'm going to go through this pretty quickly. I hope you get down with your distance formula pretty well. So for AB, I got 2 minus 0 is 2, squared is 4. 3 minus 0 is 3, squared is 9, so that gives me the square root of 13. For BC, 4 minus 2 is 2, squared is 4. 0 minus 3 is negative 3 squared, which is 9, so 4 plus 9 is radical 13 again. And then for AC, that's just a horizontal line, so I can count over 1, 2, 3, 4 units. Now I'm going to look at the corresponding parts in the big triangle. So AD, DE, and then AE. So for AD, that's 6 minus 0, which is 6, squared is 36, and 9 minus 0 is 9, squared is 81. 36 and 81 is the square root of 117. For DE, 12 minus 6 is 6, squared is 36, 0 minus 9 is negative 9, squared is 81, 36 and 81 is the square root of 117, and AE, again, that's a horizontal line, just count over there and I get 12 units. Now what I have to show now is that all of my corresponding parts are proportional. So I'm going to start with the easy ones here, 12 divided by 4, which we know is 3. But I have to show that that's exactly the same as it is when I divide my other corresponding parts. And if you put those into your calculator, which is pretty hard to do by hand, but if you put it into your calculator, you'll see that all 3 of these have exactly the same ratio, which is 3. And so if all of them have the same ratio, then I can kind of wrap this up with like a summary statement, and I could say, yeah, the 2 triangles are similar by side, side, side. So why don't you try one of these now? I'm going to give you just a little bit different picture, but really you're going to do the same idea here. So you're going to look and see if you can prove that triangle ABC is similar to triangle DEF. So as soon as you see these points written on the screen, go ahead and plot those and then do the work. Compare with a partner, and once you and your partner are in agreement on how to do the problem, then you can go ahead and finish up the homework assignment as well, and I'll answer any questions when I see you next time. Alright? Thanks for paying attention. Continue to work hard at this. Ask questions as you need tomorrow. And again, work with a partner right now to try to make sense of this last example problem and the homework problems that you're going to do for tomorrow. Alright? We'll see you next time.